Hi, everyone. I'm Owen.
And I'm Scott, and this is our poster on equity in post-HCT survival predictions. HCT is a medical procedure in which a patient receives blood-forming stem cells from a donor. This original problem was proposed on Kaggle, and the problem is that current predictive models often fall short in addressing disparities related to socioeconomic status, race, and geography. The solution to the Kaggle problem incorporated a wider breadth of information for each sample. This complicated analysis and top solutions used extensive feature engineering to form a regression model. Our problem with those solutions is that doctors are already overworked, and we need a simpler method that allows for future features to be added without high modification. Our proposed solution is to demonstrate deep learning feasibility for learning a model that can make predictions with minimal feature engineering. Deep learning approaches to risk estimation offer improved scalability and flexibility compared to regression techniques that heavily rely on robust feature engineering. And by using a neural network to estimate the risk of HCT, uh, we build upon the work of competitors and we continue to improve fairness in healthcare decision making. The data that we worked with included some expected data such as sex, age, and obesity. And it also had additional demographic information for each patient, like their race or ethnicity. And we also had information about donors, like whether or not they were related to the subject. For our pre-processing, we used a pretty simplistic approach. For fields that were not numeric, we used categorical encoding. And then for all of our numerical fields, we just replaced NaN values with -1 because they were all non-negative. This preserved the information of the data set while still keeping the invalid entries separate.
Now, since our goal for this was to have a product that doctors can enter raw data into and get good results without the use of extensive feature engineering, um, and the data all being encoded by us as numeric, we didn't feel the need to go beyond a fully connected network as seen in the architecture section, as none of the more complex architectures seem to provide any immediate benefits that could improve performance. The only interesting thing that we really came across was our loss function, which had to be negative log likelihood. And we had to use this due to its ability to handle both whether a patient had suffered from an event, how long it took for that event to happen, and because some of the data is censored, as in we don't know what happened to the patient, if they experienced their event or not, and when they did. And this is a function that we have never used before. Now, for our evaluation, the evaluation of the model's performance, we are using the stratified concordance index. This index is often chosen in survival estimation processes for, again, its ability to handle both whether the event happened and how long it took to happen, and it is robust enough to handle all the censored information that often comes within existing medical data. And we use it to ensure more equitable outcomes across groups, as the standard concordance index is not up to this. So we don't want to sacrifice, or rather, we don't want to overrepresent one group at the expense of another in our results. Now, onto our performance. We achieved a stratified C-index score of about 0.6, while the winner achieved about a 0.7. Keep in mind that the winning solution spent a lot more time feature engineering than actually predicting the model. As we mentioned, they were more using regression models by the end of it. And we are still starting to encroach upon their performance, even when working with unfamiliar data, unfamiliar loss functions, unfamiliar evaluation methods, and we had never heard of any of this stuff before, so we think we did a pretty good job given the time that we had. And we think that despite our inexperience with this type of data and the simplicity of our model, along with the limited time that we had, the early results are promising enough that we hope that going forward, others who are more familiar with this data type and these evaluation loss functions can improve upon these methods and improve the performance of future models, making predictions easier, more accurate, and more equitable. Thank you.